Okay, so this is 2019 higher level question. I have my exam papers here. This is an image of a bridge in Drogheda. So basically the first thing we need to do is we just look at the scale first. So the scale is 1 to 100, so it's going to be quite easy. It's going to become 81, this will become 25, 252, it's going to become 18, etc. So to divide by 100 is relatively easy. It keeps them roughly the same. But the first thing we want to do is we want to highlight the parts of what they want us to do, and also to double check what the shapes are, because sometimes you may assume. So for example, this looks like a parabola on rough inspection, but it may not be. So it says the curve ABC in elevation is a parabola with a vertex at B. So curve ABC in elevation is a parabola, vertex, turning point, draw the given elevation. We'll then do part B as well, but we leave part C maybe for another video. So the curves DEF and PQS are the plan of a double hyperbola. Okay, so a few different ways of doing a double hyperbola. The vertices are E and Q. Okay, so that's important. The construction of the portion of DE is shown, and HLG is a straight line. So HLG, so this part here is a straight line. So this obviously we have to figure out something to get our curve here, and it also may affect where we're going to position our plan, because I probably would have came down less, but I'm just looking at where the center point is there if I want to show that construction easily, but I'll be able to show it on the other side and mirror it across anyways. So that looks to be our main parts of the question. Again, they show us the construction for this. So double hyperbola, this is a method that we use for the question C2, the structures question, shell structures. So some people may or may not do this as an option, and also this is one of the methods for doing it. So at least if they give us a hint, most of us should be able to attempt it. So we're going to start off, we're going to draw the elevation first. 81 is our height, so we'll come down about 100 to start. Okay. So that'll do for, I'm going to zoom back out there. Okay, so straighten up the board. So I'm down about this to start. And we're not asked for an end view in this case, so we'll be fine. Okay, so my XY line there, and then what I'm going to do is I need 252 space. So actually it's quite a large drawing. My other set square won't push 252, my 60-degree set square. I think 230 is the height of what it'll go to. So what we'll do is we'll pick a point here to start. I don't think I need anything on the left or the right. So we'll go to 200 and we'll add on an extra 52. Okay, so I'm going to draw a rectangle to start off, just to position my parabola in, because my parabola fits in a rectangle. And our height is 81. So because it's an uneven number, and because I typically would construct a parabola into 5 sections, I'm going to have to use divisional lines. However, I'm just going to double check whether 5 would be a good number in this case. Just checking that straight. Okay, so the reason I would check that is because I may as well use the number of divisions that they've given us here. So we've 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So double down there. So 7 gaps between it. So what I do is I may as well do split it into 7, because that way at least when I draw the lines up I won't have to go back and reconstruct them again. So the first thing that I'm going to do is 252 divided by 2 is 126. 126 doesn't divide by 7, I don't think. Maybe it does. It does actually. 126 divided by 7. So 7 into 12 goes once, and 56. So 7 into 6 goes, 56 goes 8 times. So 18 is the gap across. So we'll go 18. 36, and 18 is 54, and again you can use your calculator if you want, and 18 is 72, and 18 is 90, and 18 is 108, and we should have a gap, and 18 should be 126. So that looks good. Okay, so again 18, 36, 54, 72, 90 and 108. So there's all my vertical. Right, so I'll lightly draw them in initially. Okay, now Does 81 divide by 7? No, it doesn't. 84 is the closest number. Regardless, I'd probably do a divisional line on the side anyway, just in case they're expecting it, and just to show the examiner that you're able to do the divisional line method. Okay, so I'm going to draw a random line here. I'll take a light green to do it in. So draw a random line here, put 7 equal gaps on it. So I'm going to go every 10 apart here. So 10, 20, 30, 40, 50, 60 and 70, and drawing the last one back. Now you can use sliding set squares, or you're just one set square to split these, or space. I'm just going to use sliding set square method. So I have 2 set squares here. I'm going to hold the outside one, slide this along. My pencils could be a little bit sharper. Okay. Again, my pencil here could be a little bit sharper. So that's my 7 on the other side. Or on that side, I could do the same on the other side, but I'm not going to bother because I'm just wasting time. I can literally just project the point straight across because it's a symmetrical shape. So we have this point. All my points. I'm happy enough with there. So what I'm going to do is I'm going to mark my vertex. So they told me my vertex was B. I'm going to mark it clearly. You see, I'm going to B. And we'll join all these up like so. Okay. So a relatively simple construction, something you should have came across at junior cert level, particularly higher level, junior cert level. And a good start to the question. We'll do the same on the other side. Again, my points may be tiny bit off the thickness of the colour pencils so that you can see them, make it a little bit difficult to be as accurate as you should be able to be on the page. But for the main, you'll be able to see the method, and in fairness, the method is the most important part. So you can number these if you want. So we can call this 1, 2, 3, 4, 5, and 6, and 1, 2, 3, 4, 5, and 6. And then where 1 and 1 cross gives you a point, 2 and 2, 3 and 3, 4 and 4, 5 and 5, 6 and 6. And then as carefully as you can, sketch in your curve. So the same again on the opposite side. So you could just use a mirror method if you want for the opposite side. In this case it's as quick nearly to do it this way, but a mirror method is also perfectly fine as long as you show the construction on one side. Okay, so what I'm going to do now is I'll heavy in the wire supports that are holding up the bridge. And then we have our elevation done. Okay, so that's part A done. So it says draw a parabola, construct our bridge. We always check back just to see is there any hidden detail in it. In this case there isn't. And we're ready to go on to part B. So what we're told for part B is basically that there's double height parabola in it, but also that there's straight lines. There's some lines here that may confuse us, that are this line here is straight. So there's obviously some bit of construction here. Now we're given a measurement of 4 and a measurement of 8, and we seem to be missing a distance here. So there's obviously some way that we're going to have to construct that, and we have our various measurements that we're going to use here. So we'll come down a reasonable distance. I'll see how much space I can get with my visualizer. Okay, so I'd say we come down 80 just for the center point for the minute. And that may mean that my center of my arc that I have to draw comes up here, but that should be perfectly fine as long as I can see it on the bottom. So hopefully this will work out. So I'll draw a center line across the middle. Okay, and then we have a measurement of 4 on both sides. So we come up 4 and down 4. And they're only for a small section, so I'll draw them on this side, and I'll draw them on this side. I won't draw them the full way across just to keep it a little bit more manageable. So I'll use a pink now just to construct the rest of the outline. So we have this as our outline here. We also know then that we have to come in 90, and then we have our center line. should be another 3.6 away, which it is, and come in 90 from this side. Okay, so we have that, and we have that, and we have our construction there for it. Now if we look carefully, we can see they used equal marks here, so that's grand. 40 divides by 5, and they want to use this 90 for our space for our construction here. We need point E and point Q. So this is basically point E, and this is basically point Q. But if you want to write beside them, this is usually what we would refer to as V1. This is usually what we refer to as V2 from the previous questions that we've done. So we're basically 40 divided by 5 is 8. So we do this in a green again. So we have 8, 16, 24, and 32. And then our 90 divided by 5 is 18. So the easiest way is 9 to divide by 5, knock off the 0, add 9, add it to itself. So that gives 18. So we have 18, we have 36, we have 54, and we have 72. I think they're actually the same points as we had above there. Okay, so again, use as many hints as you can. Now we should know this construction anyway, but if you look, the points on this side join to E or V1, and the points on this side join to V2. So we'll start with these ones. As I said from previous in class, if you join them the wrong way around anyway, in this case the hint, but if you join these ones to E and you join these ones to Q, you would hopefully soon cop that they both don't cross, and it must be the other way around. Okay, so there's my points there. Okay, so what we're going to do now is, again, we can number these. So I'm just going to use A, B, C, D just for, no, I probably shouldn't use A, B, C, D because we've already used that up at the top. Okay, we'll go back to 1, 2, 3, 4. I was going to use different numbers just because I've used them up the top as numbers, but I'll keep them there that way anyway. So where 1 and 1 cross gives me a point, 2 and 2 cross gives me a point, 3 and 3 cross gives me a point, and 4 and 4. So it's basically sort of a slightly different shape to a parabola. It's more distorted, more slender basically. So that's the method for it. So for a parabola, one set of lines are vertical or horizontal or basically parallel to the outside. In this case, all sets are at random angles. So what I can do then is basically I can mirror the thing across, or I could repeat the method here for the side. But in this case, I think mirroring would probably be the easiest and also probably the neatest for the sake of drawing the question on the visualizer. So there's my various points. This is my center line here. I'm going to take my compass. There we go. First point. So I'm only mirroring the points that I found accurately. Okay. And last point. Right, there's my starting point. Okay, so there's my new parabola on that side. And I can do the same down the way and across the way. So what I'll do is I'll bring these down. And I'll also do the same here. So I'll take my distance here. Now what I should have done, because they should be the same, I should have stepped both off at the same time. It would have made things a little bit quicker, but anyways, it's a simple mistake that I made. So this distance here on this side should be the same. But anyways, just a simple thing that would have sped me up. That's what I initially planned to do, but had forgotten. Okay. No, so I have my various points. Okay, so I used the mirror method. You could repeat this method on the 4 sides. So basically, if we look at it there and we compare it, it looks like our hyperbola that we're used to seeing in our paraboloid of revolution question. It obviously is just quite squashed this way, but you can see basically like our cooling tower shape that we have it there. So we then look at what else has to go in. So we can see we have a point here for the road, and our road here is 2 of these in. So basically 8 and 8, so 16. So basically on our point number 3. So what we'll do is we'll draw that. It's a heavy line, basically, but I'm going to draw it with a purple because there is a bit of hidden detail, or maybe a blue. There is a bit of hidden detail in it that I can't tell because I haven't that bit constructed. So basically, there's my road that side, and I'll have to come down the same distance, 16 on this side. And there's my road that side. So I now have my road in. So what else have I left to get? I have to get point L and point G. So point G is basically here. So it's relatively simple if you look at it quite carefully. So G there is on my outside of my rectangle, and it's on the second one in. So basically it's where my road hits the outside of my rectangle that I used to set up to find E. Then L is basically on this one here and on point 2. And if I join the 2 of them together, because we're told that's a straight line, that gives me my point there for this. So again, I can take this on all sides. Basically this point is important, and we'll need to mirror down this point. Well, I have my outline there. So that's the same point there. And if I do it on the other side, you need to measure in 18 and 18 is 36. And 18 and 18 is 36. And just to extend this line down lightly so I know where to stop. So there's, what do they call it? L and G, basically a repetition of the lines L and G on both sides. Now again, depending on how accurate you are, it should be exactly the same on both sides. This gap here should be the same as this. And on the opposite side, again, my pencil is a little bit thick and a little bit blunt, so it may be a little bit off. But there's basically my points. And what I need now is I need to have a curve here. So this is a construction that you would have done at Junior Cert Woodwork. We know, or would we have? Oh no, we know that this is up. It's actually even simpler than that. It's just a right angle to come up at this. So if we take our adjustable set square and we set it to the angle that that produces, and we come up at 90 degrees, because we know that's the tangent point, point G. So I'll slide in my adjustable set square here. So I'm going to come up. Just check how accurate that is. That looks really good on both sides. So I'm going to go up here, and there's my center point. So it's got up a little bit on my bridge compared to the question, but it won't make any difference. It was just otherwise I may not have space to fit it on the page. So there basically is my curve. So it should be the same on the other side. So this may go off the page. So what I'll do, because it's going to go off the page in my case, I'm just going to mirror the cloth. I just think that's where I won't have space to slide on that there. Okay. So again, we have this, and that's basically the same construction. If I just was that square footed, that's where that would have come out at 90 degrees. So if we look at our question then, the only thing that we have to do is we have to just mark in these bits of hidden detail here. Okay, so basically the rest of it is completed as such. So we're going to take our heavy pencil again. Just go over our blue roadway. So again, there may be marks for heavy and hidden detail. Oh, this little bit here will be a bit dashed. This is solid. This is solid. And that's the question. Completed our part A and part B done.